another really famous experiment that was kind of conducted in the recent century, or yeah, I mean, I guess this was an experiment. The Large Hadron Collider in CERN detected the Higgs boson for the very first time. Now, for anyone who, and this happened around in 2012, like around in 20, right? Yeah, I mean, around it, because when I searched online, it said 2011 to 2013. And I'm like, yeah, I mean, it happened so recently. Why don't you know that? But I'm pretty sure it happened in 2012. But the interesting thing about the Higgs boson is that it was proposed by Peter Higgs, hence the name, and his colleague Francois Englert, but I guess Peter got the credit. So it was designed and it was thought of by both of these gentlemen in 1964. And they had been trying to find like experimental proof for the Higgs boson, obviously ever since then, but they knew that the experimental accuracy and technology was nowhere close back in the 1960s. But then, when they opened up CERN, they tried to look for this particle, but I believe that they were unsuccessful. And then, after like a revamp of the facility, and I guess a few more tries. So basically, they're just smashing particles together over here and seeing if anything gets excited enough so that they can detect them. And they detected for the very first time this particle that they had never seen before, and everyone called it the God particle that we now simply know is the Higgs boson. And the meaning behind this is because the Higgs boson is not that special because it's just a particle. What's more important is the Higgs field. The field, so much like the electric field, right? Like an electron, we were talking about it, and like an electron is an excitation of the electric field. So in the same way, a Higgs boson is an excitation of the Higgs field. So if you're imagining, the Higgs field is basically everywhere in the universe, and it is what allows particles to gain mass. So basically, in other words, when particles interact with the Higgs field, they are restricted from traveling the speed of light. So this actually answers the question for why massless particles can travel at the speed of light, because they don't interact with the Higgs field. And because they don't interact with the Higgs field, it's basically a smooth transition, and they can travel at this maximum possible speed.
And something that's pretty cool is that we actually interviewed a physicist that worked on the team that discovered, or experimentally discovered / found the Higgs boson. Dr. Pekka Sernövo, which was episode number 4. I think.
I love that gentleman. He was one of my professors for one of my classes. Amazing guy, super super cool, because he was teaching me a very low level physics course. Sorry. A very low level physics course, right? And I'm like, okay, this guy's probably, not done that much.
That is not
blown
true.
Blown away. This guy has done everything you can imagine, man.